Good afternoon, distinguished judges. My name is WORAHAKARIMA WUTTIWONG from Prince Abdullah Science High School, Nakarat. So, imagine surviving a heart attack only to discover that part of your heart will never fully function again. Today, I would like to present my project, Biodegradable Microneedle Platform for Sustained Localized Delivery of hUC-MSC-Derived Exosomes to promote myocardial regeneration. So rather than simply treating symptoms after a heart attack, my project explored a way to help heart repair itself. So let me begin with why this problem is so important. So, every year cardiovascular disease remains the world leading cause of death. According to World Health Organization, approximately 1 in every 3 deaths worldwide is caused by cardiovascular disease. And in 2022 alone, cardiovascular disease claimed nearly 19.8 million lives, making it one of the greatest global health challenges. And more than 80% of cardiovascular deaths result from heart attack and stroke. So today, thanks to advances in medicine and more patients survive after a heart attack more than ever before. And treatments such as angioplasty with stent implantation, bypass surgeries, and medication are extremely effective at reopening blocked arteries and restore blood flow. They save lives, but they cannot replace the heart muscle that has already been damaged. So today's challenge is no longer simply helping patients survive. The challenge is helping the heart regenerate. And these challenges inspire the objective of my project. So here's the objective. So my first objective is to establish minimally invasive biodegradable microneedle platform that could complement current myocardial infarction treatments. Secondly, I aim to address the unmet need for myocardial regeneration by developing a localized delivery system that targets the damaged heart tissue directly. And finally, I aim to improve the therapeutics effectiveness of human umbilical cord mesenchymal stem cell-derived exosomes through sustained and localized delivery, increasing their retention within the infarcted myocardium. And before introducing my platform, I would like to explain why I chose hUC-MSC-Derived exosomes. Okay, so first, before that, exosomes are cell-free extracellular vesicles released by stem cells that carry bioactive molecules, including proteins, growth factors, mRNA, and microRNAs to promote tissue repair. So first, they suppress excessive inflammation, reducing further tissue damage. Second, they promote angiogenesis, leading to the formation of new blood vessels and improve oxygen and nutrient supply to the injured myocardium. And they reduce fibrosis, thereby minimizing scar formation and preserving the structural mechanical function of the heart. Finally, they inhibit apoptosis, or programmed cell death, allowing more cardiomyocytes to survive after myocardial infarction and preserving the viable heart muscle. Together, the regenerative effect make hUC-MSC-Derived exosome one of the most promising therapeutic strategies for myocardial infarction. However, there's one major limitation. Exosomes disappear from the heart really quickly after injection. That limitation inspired my innovation. So instead of injecting exosomes into the heart directly, I designed a biodegradable microneedle platform capable of delivering them directly into the infarcted myocardium. The platform consists of 3 layers. As you can see from the tips, there are gel-made hydrogel, which contain hUC-MSC-derived exosomes, and the base is PCL base, which provide flexibility and structural stability during implantation. And this combination of biomaterial formed the core innovation of my project. So let me explain how the entire system works. So first, do the small incision below the xiphoid. So the xiphoid is the bone here, so below your chest. The snake jaw inspired implantation device is advanced into the pericardial cavity under endoscopic guidance, and once it reaches the infected region, the flexible grasper opens and positions the biodegradable microneedle array directly against the epicardial surface, and gently pressure allows the gel-made microneedle to penetrate into the superficial myocardium. And after successfully implantation, the microneedle arrays detach from the delivered device while the catheter is safely withdrawn. And over time, the gel-made microneedle gradually biodegrades. So every innovative therapy comes with challenges, and our platform is no exception. So the first challenge is precise, minimally invasive implantation. So the patch must be accurately delivered onto the beating heart while minimizing tissue injuries. The second challenge is control exosome stability and release. So exosome must remain biologically active and released gradually for sustained therapy. The third challenge is microneedle reliability. So microneedle must penetrate the epicardium effectively while remaining biodegradable and safe. And finally, clinically translation remains a challenge. So extensive preclinical study, manufacturing optimization, and clinical trials are needed to demonstrate safety and long-term effectiveness. So the application first, it may serve as regenerative therapy. It can provide a minimally invasive approach that may reduce surgical trauma. And third, it's enable localized exosome delivery, improving therapeutics retention to the target site. And finally, this platform could adapt it to deliver other regenerative therapeutics as well. So this is the conclusion. So I am making a detachable biodegradable microneedle array which contains hUC-MSC exosomes. So I have three future outlooks. So the first one is advanced toward clinical translation. Another one is enhanced device performance and optimize exosome therapy. And here's the references. And thank you. Yes.
Thank you very much for your nice talk. So what do you think that the exosomes are loaded?
Located?
No, I mean, so what's inside the exosome? What do you think there are inside the exosome?
So okay. So the exosome, they contain like proteins, microRNAs, and other stuff that, so I have done some research about exosomes, and so to be basically they're all like scientific names, so I cannot like quite remember it clearly, but I just know that it helps regenerate the heart. Yes.
Okay.
I also have a similar question. So what contents in the exosome can contribute to the regeneration or myocardial?
Oh, so you mean the specific content that help regenerate the heart, right?
No, in the exosome. You said RNA, microRNA, protein in exosome. So what can really contribute?
So what really contribute to the
regeneration?
Oh, okay. I think so basically I didn't dive into the what is the key reason that help the heart regenerate. So I think I should do like some more research about this too.
And also, additional question is, when you inject the exosome into the myocardium, so the needle need to be stay there, or just you're going to remove
so
that?
it will. So I choose the dissolving microneedle, so it will biodegrade over time. So it will stay there.
Why is it the needle need to be degradable?
Because so when you do surgeries, it's really hard for you to to take it out from the patients because it will have a high risk. So this microneedle I plan it to do so some patients who need to cure with the PCL method, they have to put the catheter into the blood vessel, right? And so I think I can combine this together and help make it better by we can put this microneedle in too. And I want it to be biodegradable because so that we didn't have to take it out and it will be safe for the patient as well. Yes.